Welcome everyone. So in today's video we will learn about the architect of 8051 microcontroller. So 8051 microcontroller consists of interrupt control block, on-chip ROM memory, RAM memory, two timers and counters, serial port and four input-output ports, bus control, oscillator and a CPU. So let's learn them briefly. 8051 microcontroller consists of two external interrupts and three internal interrupts which come from a ROM. And there are total five different types of interrupt which we will learn in our upcoming videos. But for now, just remember that there are two external interrupts and three internal interrupts. Now let's go to the ROM. As we have learned in our previous videos, ROM consists of the 8051 consists of ROM and RAM. ROM is of 4 bytes and RAM of 128 bytes. Okay, but if we are performing something that requires much more space, then we can attach a external memory to it, which can be expanded up to 64 bytes. Okay, the 8051 microcontroller consists of two timers and two counters. What are timers and counters? We will learn it right now, just a little bit later. And it consists of one CPU which performs all the operations, oscillator which oscillates, which synchronizes the internal and external operations. Okay, the thing which is going on inside a microcontroller and the program which is running outside the microcontroller, it synchronizes those two so that the microcontroller runs perfectly. Okay, bus control, it consists of two data bus and address bus. Okay, we'll learn about it later. And four input output ports and a serial port. So let's take a look. I guess you people know about bus control, which is address bus and data bus. Here a serial port is new and timers and counters are new. Okay, and our oscillator is new. And you must know about interrupts and all other things. But yes, these oscillator, serial ports and timers are new. So we will learn about them briefly. So what are timers and counters? There is their main purpose is to count time and measure external events. Okay, the main purpose of timers and counters. So in 8056 there are two timers and two counters. Timer is used to generate a time delay between each instruction, and a counter is used to count the events happening outside the microcontroller. as i have told earlier as I have told earlier, that there are two things going on simultaneously. Okay, the the thing which is going on outside the microprocessor and operation which is going on inside the microprocessor. Okay, and the oscillator will synchronize those both, which means it will do something through which it will work same both will work at the same time. As I have written also here, that oscillator, what is the main work of oscillator? The oscillator circuit generates the clock pulse so that all the internal and external operations are synchronized, which means they all run simultaneously at one time. Okay, and what is the meaning of serial ports? 8051 includes an on-chip serial ports. Operator operates in four modes over a wide range of frequencies. So as you have learned about data communication, when we transfer data from one port to another, we have a transmitter which is transmitting the data, and we have a receiver which is receiving the data. Receiver is known as RX and transmitter TX. Okay, so what serial port does is it performs parallel to serial conversion from output data. The data which we are giving as output, like you must have learned about it in data communication, that we can transfer data in two modes, in parallel mode or in serial mode, like this. Okay, so yes, so the serial port perform parallel to serial conversion and serial to parallel conversion for input data. So we will learn about serial ports more briefly in our upcoming videos. Okay, for now this is enough. So now you have learned about timers and counters, serial ports and oscillators. Let's learn some basic applications of mic architect of features of 8051 microcontroller. 4 kilobytes of chip program memory, 128 bytes of chip data memory. This is RAM memory, 128 bytes. Remember this. This is RAM and this is ROM. Okay. And in 8051 microcontroller, we can add an external memory. Okay. 4 register banks, 128 user-defined software flags, 8-bit bidirectional data bus. As I have told you that 8051 micro controller was having a bus controller. Okay. And buses are address bus and data bus. So data bus is of 8-bit and address bus is of 16-bit, which is unidirectional, which means only in one directional, and bidirectional means it can operate as input and output in both the direction. 32 general purpose registers, each of 8-bit, 16-bit timers. Okay, as I have told you, there were two timers present in 8051, which are both of 16 bits, which means 8-bit each. Three internal and two external interrupts. As I've told you earlier, there are three internal interrupts which were generated from ROM. Okay, and two external interrupts which we can program and give it to the microcontroller. 16-bit program counter and data pointer. This point is not that much important. Okay, so till now what we have learned is that a microcontroller or 8051 microcontroller consists of two external interrupts and three internal interrupts, two timers and counters, a serial port, RAM and ROM, which is of RAM is of 128 byte, and we can add external RAM. Okay, also add external RAM, and ROM is of 4 bytes. And a bus which consists of data bus and address bus, four input output ports, which is P0, P1, P2, and P3. Okay, P2 and P3. This make it four input output ports and an oscillator through which we can synchronize the operation which is going on inside the microcontroller and the operation which is going on outside the microcontroller so that they work simultaneously at the same time. So this was the architect of 8051 microcontroller from inside. Let's look at the pin diagram of 8051. See, as you can see in the pin diagram, as I have told you uh, earlier, that there were four input output ports. So one, two, three, and four. Okay. So as I have told you, there are four input output ports in 8051 microcontroller, and these are the four input output ports. Now, let's see what each of the port is doing. Let's see what each port is doing. Okay, I have written it down for you guys. So pin 1 to 8, which is input output port 1. Okay, see, pin 1 to 8. Pin 1 to 8 is P1, input output port. What it as the name suggests, input output port, so the port doesn't serve any other functions. It only serves bidirectional input output. That means we can add input output devices through this in bidirectional. We can give input through this and we can take output through this. Okay, now pins 9, which was a reset pin, and as the name suggests, it resets the microcontroller, which is used to reset the microcontroller to its initial values when we are programming or when we have given any information or program to the microcontroller. After the work is done, we press the reset key to reset the microcontroller. Okay, pin 10 to pin 17, these are port 3. Let's see, port 3, as you can see, pin 10 to pin 17 is port 3, and this port consists of this is not a normal input output port like P1. Okay, because it has various other tasks. It has tasks such as transmission of data, receiving data. It has two what were these interrupts? Okay, external interrupts. It has two external interrupts present in it. These were timers. Okay, T0 and T1 are timers, and one write function and one read function. Okay, so this is not a normal input output function. It has various other functions such as receiving data, transmission data, two interrupts, two timers, and read and write function. Okay, Now, po port 20 is giving the power supply, and port 40 is also giving the power supply. Now let's look what other ports can do. Port 20 to 28. Port 20 to 28, these pins are known as port 2. It serves as input output, higher order address bus signals, also multiplex using this port. This is also not a usual, sorry, this is not also not a simple port, okay, which was this port 2, this one. See, there is written A15, A14, A13. As I told you that address bus was of 16 bit and data bus was of 8 bits. And where is data bus? Data bus is present here in port 0. See, AD means address bus, data bus. Okay, so data bus is of 8 bit and address bus is of here 8 and here 8 16 bits. Okay, so so here this port 0 can be used for multiplexing address bus and data bus, and port 2 can be used for multiplexing only address bus, and port 3 was used for various different functions such as receive, transmission, two interrupts, two timers, and write and read function. And port 0 was a normal input output function. These can also work as an input output function, but yes, they have also some other functions. Now let's look at port 31. Okay, what is port 31? So port 31, this is a EA pin which stands for external access input. Now let's assume that we are performing a function as and our memory and that functions take a huge amount of space, so we have to add an external memory. Okay, so this 31st port, which is EA external access, it is used to enable or disable the external memory interfacing. Through this port, which is 31, we can connect the external memory. Not, we cannot say we can connect, but yes, it can disable or enable with when we apply 0 or 1, it can disable or enable the external memory. Okay, this is the function of uh, 31 31st pin. Now let's see about 30th pin. 30th pin is your ALE pin, which stands for address latch enable. It is used to demultiplex the address and data signal of port. What is demultiplexed and what is multiplexed? If you know it already, it is simple for you to understand, and if you don't know, let me explain you. Multiplexed means when we are sending address bus and data bus together, that means they are multiplexed. And demultiplexed means usually means separating address bus and data bus from each other. So this port, 30th port ALE, is separating address bus and data bus from an address bus, and data bus was multiplexed in this port 0. Okay, so this is used to demultiplexed this address bus and data bus. Now let's see what is this 29th PSEN do. PSEN pin do. So 29th pin is this PSEN pin, which stands for program store enable, is used to read a signal from the external program memory. Okay, let me explain. This EA pin was external access enable. This was enabling or disabling the external memory, and this pin is used to read. It is used to read the external memory. When this 30th pin enables the external memory, then there is external memory, and this 29th pin is used to read that external memory. Okay, and what others are left is 40th pin, which is used to do ground, and I've told you all the other. Let's look at quickly. This is simple input output port, address and data bit. Address and data bus ports. This is only address bus port. It is used to enable or disable the external memory, and PSN used to read the external memory. ALE. What was ALE used for? ALE was used ELU was used to demultiplex this address and data bus from here. ALU is used to demultiplex this address and data bus. It has multiple, and port 3 has multiple functions: receive, transmission, interrupt, timer, read, and write function. Okay, so that's it for today's. That's it. That's it for today. In our upcoming videos, we will learn more deeply about this timers and serial ports. So, thank you for watching this video.